Hey there, controls people. We're going to do a look here and discuss troubleshooting a low oil flow indication on a ball mill. So, to give you some context, problem is a low flow indication in the oil feed to the ball mill. DCS alarm. The guys had known about it for a while, kept showing up on the morning meet, and should be part of ball mill maintenance. But there's a few things that I wanted to bring up because controls should be interdisciplinary and not just stuck in programming or electrical or having the electrical knowledge to understand hydraulic schematics and how that might come into play. So first I have some basic hydraulic schematics that you can find in your AutoCAD electrical library. Hydraulic tank, a filter, hand valves, and the purpose of this is so that we can control the direction of flow, and then also if you had to change out the pump, then you want to be able to isolate that pump to drain it and change it out. And then what if you need to turn it off going to the device? And this is just a generic circuit. It's not the device for the oil flow problem. But you should be able to isolate everything and put it in a recirc so that you can be ready for when the device calls for it. Pressure relief, that's what this little symbol is. That's so that you don't over pressurize your pump. Valve direction, or just a regular valve. Or pneumatic valve. And then obviously filters come into play with oil or hydraulics because you don't want junk going into your system, and then you have to be able to keep a clean tank. So keep those in mind for a second. And I'm going to mosey on. So those are basic hydraulics that I had to be aware of for this job that I was doing. And then if I look at oil going to the ball mill, here's a circuit that you might get on a design. And if you're having to review the design, or if you're on an interdisciplinary team, then you should be able to come over here and say, look, I need an extra pump because if this fails, I need to fail over automatically because it's a critical function. And those are the types of decisions that controls should be making in the design, and not just programming. So the other issues would be, or the other indications that you may want in this type of system is flow, temperature, differential pressure on the filters, because you want feedback on when the filters are plugged. They should reach a certain point so that you can keep a KPI and change out the filters. Tank levels are important because you want to know if you get a leak. Pump indications, you should know when the pump is running, which pump is running, which pump is primary, which pump is secondary, how many hours are on that pump, and then auto manual, and then a pump failover at a high pressure or a pump failure. You may not get a high pressure on a pump failure. You may get no flow. And so, these two are combined. You may get a high temperature on a pump, depending on the size of the pump or the pump motor. And that may be an indication. And, I always like to have these on my auxes coming back so that I know if I'm running hot. All of those things may be an indication that there's a problem. Those are design components that filter over into maintenance, because if you have good design, then you have good maintenance, because you're giving them the proper indications to set up their KPIs to change out equipment. So in this case, what I had was a basic flow meter with a magnet type indication on it, and we had flow through it, and it was totalizing, and then a 4 to 20 feedback back to the HMI, and oil was coming from the reservoir going into this ball handler that was breaking down the after clinker balls and making them smaller to put cement into a powder, and oil has to go in on the gears to keep this thing moving. You have to get oil on every single tooth in that gearbox. To give you an idea, this is what it might look like from the side. And then if we go to this website, how cement is made, we can see the whole cement process. So this here is getting it out of the mine. We're taking it into the field. So quarry, primary crusher, grinding and blending, preheater tower, this is the kiln. So the ball feeders are after the clinker, and so kiln, formation of the clinker. The baghouse is for your emissions. Clinker is where it's cooled, and then we're going to go baghouse, and then we're going to go one step further, and there we have the ball mill. So as the clinker is cooled, it's ground into smaller amounts of gypsum, limestone, and other ingredients to make cement. So you also have other ingredients mixing in here as far as to compensate for this. And that's putting it all together. And then also it has actual balls, marble-sized balls that are, I don't know, about 3 inches across, and they are banging around in there, and it's absolutely huge. But with that in mind, you can see that if I don't have oil flow on each side of these, then I have a problem, because it'll come to a screeching halt, or you'll break your gearbox or your liner, and there'll be an issue. So that is the importance of getting a proper indication as far as flow, and this is a good bird's eye view of what the gears might look like. This one is absolutely huge. This is more about the size that we were working with, and just to give you an idea, if you want to go and review this hydraulic symbols online, it gives you an indication of what every single one of these hydraulic symbols are. So I get design questions, I get maintenance questions, etc. The bottom line is that you know, as a engineer that is multidisciplined, you're not going to know everything, so you should be able to know where to go and look it up. Now, with that in mind, you also have the ability to look in AutoCAD and see it in AutoCAD and use the AutoCAD library. So this is in AutoCAD Electrical, and you have the ability to do hydraulics and pneumatics in AutoCAD Electrical, just to keep that in mind. And back to this. So what we ended up doing was this kept failing and not giving me a proper indication to the DCS, because it kept breaking down. So like we could take this guy apart, and if you looked on the inside, you know, it had like this little reservoir thing and then a paddle, and the teeth in here were just breaking down because we would get junk, and then as soon as that junk would get in there, then this paddle would stop, and then no flow indication, and then I alarm. So then we got to go back to design, and it's like, okay, And FlowMac is not necessarily the one that we had. I'm just using that as an example. And then also the one that we had was super old. So, but you got to go back and look at the design and say, is this the right instrument for, viscosity? Did we change oil? I mean, there's all these things that come into play. And then also this is like super slow. So we were only looking at 4 gallons per minute. You have to make sure that your instrument is set up properly for the flow, and that can get that granular at a low flow. It's a super low flow to be able to monitor. And that's why they use the paddle, because the paddle doesn't care how slow it goes, but sometimes the components on the inside are too plasticky or too, they get ate up for whatever reason, especially if you get particles that are coming out of here that are going back through, like in your like in this feedback going into the hydraulic tank or oil tank. If it shows back up down here, then you're likely, if your flow meter is after your pump, you're likely to be able to see material coming into the flow meter, and you're at risk of having it break down. So those are the types of things that you got to keep in mind when you're troubleshooting something as flow. The other issue may be that, maybe your line is broke between here and here. So we also checked power to make sure that we had power going to this meter. Or I should say I checked power and directed the electricians to check power, because this was my ball game. And then also, like I said, the type of flow meter, and then your you can always take your 4 to 20 going back to the DCS and stick your fluke on there and generate a 4 to 20 signal, so that you can check out this whole link going back to DCS. There'll be a terminal block on the DCS side before it goes into the DCS PLC, so that you can transfer, you could actually break it down from the terminal to the HMI. So you can break it down there, or in this case we were able to take it off and do field all the way to the HMI screen and have the operator tell us, we just broke down the 4 to 20 and gave him 4 equals 0, 20 equals 100, 12.5 roughly equals the 50%. So we gave him the whole range, made sure that what he saw equated to 0 gallons per minute all the way to 4 gallons per minute and a 2 gallon mid-range. So I knew that I was okay from here to here. I knew when I broke this apart and saw the paddle broke, that's why that the meter wasn't indicating right. We actually had parts on hand that we could replace it and put it back in, and so we got a different meter. And the people that we were working with gave us a more modern flow meter. But the whole point to this is also just not only about troubleshooting, but a good designer will take all these things into account and the process and implement these kind of feedbacks into your hydraulic or oil system or pneumatic system, so that you can get the proper indications on the HMI to allow proper maintenance feedback. And proper maintenance feedback from a good design allows you to where would it go? Control click. Let's do the control click. Allows you to do good maintenance. So, and this link is just from a Geeko group talking about regular ball mill maintenance. Part of that is making sure that we're lubricated properly. And that's one reason why we monitored the flow for this oil going through. And as we all know, I can tell you right now, this does not necessarily happen as far as replacing the lubricant every 6 months. That depends on a lot of things, but it's always about getting the widgets out, correct? So, anyway, so this has been a review of hydraulic symbols, how to look at those from a control standpoint, and a small troubleshooting scenario with a ball mill oil flow problem. And I hope you enjoy.